Let's talk about angles now. So what is an angle? Well, what is an angle? Well, an angle we're thinking of, it's the figure that's formed by two rays, here they are, ray BA and ray BC, where B is the endpoint, where they intersect at that common endpoint. And we call the two rays, we call them the sides of the angle, and the endpoint where the two rays meet, we call the vertex. And in a lot of cases, we'll deal with angles that come from two line segments meeting, and we'll just pretend that they're rays that extend infinitely far in this direction so that we can use this definition. Now, to name an angle, we just use this little angle symbol here, and we just write down the vertex as the middle of these three here. And on either side of the name, you put a point from either side of the angle. So we could label this angle here as angle ABC, ABC, or CBA is fine as well, CBA. Or if there's no confusion, sometimes we can just label it by angle with the vertex there. In this case, we could label it angle B because there's no other angle around that has B as a vertex. But if we had something along this situation, if we drew this blue line here, and this blue line was, say, had a point D, well, suddenly we can't talk about angle B anymore because that's unclear. We don't know if we're talking about ABC, ABD, or CBD. So in this case, we don't want to use just the vertex as the name. And I'll just erase that just to make my diagram a little cleaner. Now, when we do have an angle, we want to talk about the interior and exterior of the angle. And what does that mean? Well, if we draw a circle around our angle, where the center is the vertex of the angle, so imagine that this is a circle. It's not the best circle, but that's fine. The interior, which I'll highlight here in blue, is the space between your two sides. So this is the interior of your angle. And the stuff on the outside is, of course, the exterior of your angle. Okay, so that's what I mean by an angle. Now, in a lot of cases, we want to talk about the size of angles relative to other angles. For example, here's an angle here, and here's an angle here. And clearly, just qualitatively, we can look at it, and we could say the angle on the right is a wider angle than the angle on the left. So we want to give numbers to that. And the way we do it, so for measuring angles, what we do in some sense is we ask what proportion of a circle centered at the vertex is in the interior. So that, in some sense, is our fundamental question. That's how we come up with a measurement. And of course, you can see here, if I draw a circle around both angles where the vertex of the angle is the center, you can see here that in the interior, in the right angle, there is a higher proportion of the circle. So that's what we mean by measuring angles. Now, of course, we have units for these things because sometimes it's not that nice to work with fractions all the time. But in some sense, we could say that if we have, say, oh, that's not what I want this. If we have this angle here, which I think most people will know is a right angle, if I draw a circle around it, and again, it's not the perfect circle, but hopefully you get the idea, then the interior is this bit in here, and it's pretty easy to say that this is a quarter. Oh, I want this guy again, sorry. This is a quarter of our circle. But again, there's some other units that we can use. So that's what we're going to talk about now, is the units of measuring angles. The two most common units for measuring angles are degrees and radians. So let me explain what each of these are now. Degrees are going to be the one that we're going to focus on for this course. Radians are useful more when you get into, say, calculus or higher math courses. But for our purposes, the degrees will do. So what is a degree? One degree is just a 3/60th of a circle. So if you draw a little angle or a wedge, 1 degree is just 1/360th of a circle. And you could ask, well, why did we decide that that was a degree? And the reason is because 360 has it's a number that has lots of factors. So you can easily talk about fractions of a circle and angles, therefore, without getting into decimals or fractions of a degree. So half a circle is, let me draw some examples here. So there's my circle. So half a circle, well, let me try copying this first. Let's see if this works. It does. Let me get a couple of these guys. And let's even do one more. So half a circle we can express quite easily. So if we want to express half a circle in degrees, well, that's just going to be half of 360. So that's, if we do this, well, 1/2 of a circle is going to be something over 360. And we can solve that little proportion. I'll leave that as a little exercise to you guys, but I think it's pretty obvious that we get that x is 180. So half a circle, this angle here, is 180 degrees. We can talk about 1/3 of a circle. So this is roughly 1/3 of a circle, say. What is that going to be in degrees? So let's go ahead and shade that in. And we can play that same game. Oh, I keep doing that. I want this pen. So 1/3 of a circle, how many degrees out of 360 is that going to be? Again, let's solve for x here, and I'll leave that as an exercise again, but you should see that x is 120. So this angle here is 120 degrees. And this, I should say the symbol for degrees, if you don't know, this is 180. The symbol for degrees is just that little circle above there. And remember, a degree just means a 3/60th of a circle. So half a circle is 180 3/60ths of a circle, which is half your circle. And this is 120 degrees. 1/4 of a circle, I'll just draw these in, but you can check them the same way. This is, of course, 90 degrees, and we usually use, instead of that angle marking, we usually use a square for a right angle, a 90-degree angle. 1/5 of a circle, that's something along the lines of this. What's that going to be? Well, again, set up your proportion. And if you solve this, I'll leave this as a little exercise, but as a reminder, just cross multiply and solve for x. You should get that x is 72 degrees. Notice that we haven't got into any decimals or any fractions yet. We all have answers that are just degrees without pieces of a degree. So that's great. 1/5 of a circle is 72 degrees. Awesome stuff. And I'll just tell you, 1/6 of a circle is 60 degrees. 1/7 of a circle, it fails. So we are going to end up with pieces of a decimal pieces of a circle. But 1/8 of a circle is 45 degrees. 1/9 of a circle is 40 degrees. 1/10 of a circle is 36 degrees. So you can see there's lots of different fractions of a circle we can talk about without getting into decimals. So that's why we picked, it's just a choice, that's why we picked 360 as the denominator for what a degree is. A radian we're not going to get into too much, but I should explain what it is. A radian is the angle here when you have a circle with radius, let's say r. When you go up and you measure, this is called the length of the arc of the circle, until you get the same measurement as the radius. So when they are the same, the angle that allows that to happen, that's 1 radian. So this is 1 radian. And I'll tell you that's roughly 57 degrees, something like that. But we're not going to worry too much about radians in this course. We're just going to be talking about degrees. One more note here. I want to talk about notation for when we measure an angle. So let's say this angle in our second circle, that's 120 degrees. Let's call this vertex V for vertex, I guess. And there's kind of only one angle around. So we can just call it angle V for this point, or at this point. But if I want to talk about the measure of it, I use this notation. I use an M. So the measure of angle V is 120 degrees. So that's how I write the measure of an angle. I put M and then the angle in brackets. Think of it like a function. Okay, let's talk about different types of angles that are going to be important. This is just kind of a jargon thing. But let's say we have the angle ABC. When we say an angle is acute, what we mean is that the measure of it is going to be between 0 and 90 degrees, not inclusive. So between 0 and 90 degrees. So that's an angle that's not as open as a right angle. So something like this. Let's do it in blue. So here's an example of an acute angle. An obtuse angle is going to be bigger than 90 degrees. So from 90 all the way to 180 degrees, not including 90 and not including 180. So something like this. Here's A, here's B, and here's C. This is an obtuse angle. A straight angle is exactly 180 degrees. So if we say an angle is a straight angle, oh, sorry, this should be ABC. I missed putting my C there. The measure of angle ABC in this case is 180 degrees. So what does that look like? That looks something like this. So here's my B, here's my A, here's my C. And this angle here is 180 degrees. That's a straight angle. A reflex angle, we're not going to run across this too much, but we can think of the other side of angles. They're angles that are bigger than 180 degrees. So they're angles, in fact, we'll write it like this, where it's bigger than 180 degrees. But it's smaller than 360. And we won't get into angles that are 360 degrees or bigger, because then you're kind of looping around. We won't care about that. So that's something along the line. So if we have any angle at all, maybe something like this. This is A, this is B, this is C. If we're interested in the other side of the angle, kind of the outer side, that's a reflex angle. And a right angle, of course, is when the measurement is exactly 90 degrees. So something like that. Remember, we usually use a little square instead of that round angle marking to indicate a right angle. All right, a quick note about marking commonalities in geometry. If we have two lines that are parallel, the way we mark that on a diagram is we usually just put a little arrow that's facing the same direction. Or it doesn't have to be one arrow. Maybe there's different sets of parallel lines. So if you want to mark different sets of parallel lines, maybe instead of one arrow, one set of the parallel lines will have two arrows, for example. Right angles are marked with not just an arc, but a square. So if you put a square here, people know that the angle is indeed a right angle. Now there's this idea of congruence, and basically congruence you can think of as meaning things have the same measurements. So if two line segments are congruent, say AB and CD, it means that the distance between those points, or the length of the line segment, they equal. So the length from A to B, the length of that line segment, is the same thing as the distance from C to D, the length of that line segment. And we mark that just with a tick on each line to say they're congruent. And again, if you have some more congruent lines around, for example, if these two lines were congruent and we wanted to say they were different lengths than these two, we'd put a different amount of ticks. So in this case, 2 ticks. Angles are congruent when they have the same measure. So these two angles ABC and DEF are congruent exactly when the measures of them are the same. So if these are our two angles, A, B, C, and D, E, F, then to show that the measures are the same, they have the same measurement in degrees, then we just put an arc there. And again, you could use a different amount of arcs on sets of angles that are congruent, just to say that this set is all congruent to each other and not to the other angles. So for example, we're going to talk about this a little bit later when we talk about triangles a little more, but this is an isosceles triangle. It has two sides that are the same length, that are congruent. It has two angles that are congruent. The third angle is not congruent to the other two, and neither is the third side. So I use a different demarcation for that to show that they are different measurements. Hopefully that is clear.